Okay, so today for the review, guys, for the review, we're gonna go over this. Yeah.
Can we move the test back now, because we got our other test moved back also. I can use the extra day to study. I work all
Your let's just keep the schedule, and it's gonna be fine. You just make sure you're thorough with this test, and you'll be good on the exam. I can tell you that. So this is the sample test. The first problem is just finding the z transforms, right? And this is fairly simple, right? And the first one is just two delta functions. The delta, I think, n minus 8 plus delta n plus 8. So what's the z transform of a shifted delta function? I mean, you guys should be thorough with this stuff by now. Yeah. Yeah. And did you guys get a chance to look at this document I sent out? So it's got a summary and all the formulas you need to remember in the first few pages, and then hints on working the rest of the homework problems. So right here in the list of formulas, it's z to the negative a. So this is going to be z to the negative 8 plus z to the positive 8. Now what about the ROC for this kind of a z transform? Yeah, z should not be infinity, and it should also not be 0, because if it's 0, this term becomes infinite. So the concept of ROC, where we've seen it till now, it was for sequences like these, and there we wanted the transform to converge. This whole series, to force it to converge, we define an ROC, a certain area in the z plane. Yes?
Sorry to interrupt this, but most of us are talking, and we would really rather have it pushed back to Wednesday. Because we talked to our other professor, and that's why we had it pushed back to Monday in his class. So we can have an extra couple days in this class.
So that'd be great. People with heavy work schedules and kind of things.
You might not.
Are you gonna come to class Wednesday? If so, what does it hurt? If you're gonna skip class Wednesday, I understand. Back to back, we have all next weekend. If you've got the weekend, your schedule's not that busy.
We could convince Wash to push it back another week.
I'm not gonna make any changes in class today, but let me, like, I'll post a poll on Blackboard, okay, and let's see what do you guys really want. And the other thing is,
Opinion should be heard, that's all.
I'm gonna have to do the review. Yeah.
That's 2 out of what?
Okay, so I'll let the other people speak as well. And the thing is, I don't have anything else for today. This is all I can do in today's class. So I'm gonna have to do the review today, irrespective of the exam. Whether it's on Monday or Wednesday. So we have to go through with this, and on Monday maybe we'll start material for the third exam, something like that. But let's finish this off, and you let me know through the poll, through the survey, and then I'm okay with moving the date. It's okay. So again, for this to be consistent, to not become infinite, z should not be infinity and z should not be 0. So that's the ROC. Another way of writing it is z less than infinity greater than 0, because it excludes both 0 and infinity, and either one is fine, this or that. And the next one, it says a to the n u of n. Do we have to work this out? You all remember it's 1 over 1 minus a z inverse. The ROC is, since it's causal, it's mod z greater than mod a. Right there. Next one is n a to the n un. So this follows what you did in B. So you already have the z transform for this sequence, and you've just multiplied it with an n. And you remember n x n means, yeah, negative z times the derivative of x of z. So the x of z for this guy is this. So the z transform of this guy is going to be negative z times the derivative of that. And it's okay to leave it here. The next one is cosine 2n, and a cosine, you just need to, every time you see a cosine, just write it as a e to the j 2n plus e to the negative j 2n, right, over 2 u of n. And this thing right here, it's basically two separate sequences of the form a to the n u of n plus b to the n u of n. This guy would come out to be like half of e to the 2j to the n u of n. This guy comes out to be half e to the negative 2j to the n u of n, like that. And you just proceed from there like you did before. And when writing the ROC, remember that here, for example, the ROC is going to be mod z greater than mod this guy. And does anybody remember the magnitude of this one, right? It's just a complex exponent. There is no magnitude to it. It's just one unit magnitude. So the ROC simplifies to just this. And it doesn't matter what you have here. E to the j anything, the magnitude is always going to be 1. Okay. Now the last one, n minus 2 4 to the n u of n minus 2. So it's a combination of this kind of a thing, and then the time shift thing, and then the multiplication thing. So it's 3 properties rolled into one. So first you're gonna take care of the time shift, because you don't see this right now, and it hasn't been simplified to this yet. So first take care of the time shift, and you need to make sure all the n's appear as n minus 2 somehow. So right now you have an n minus 2 here, another n minus 2 here, but this is just an n. So to force it to be n minus 2, you can do a minus 2 plus 2 kind of a thing. So it ends up being n minus 2 4 to the n minus 2, and a 4 square, that's just a constant that can move out, u of n minus 2. So because of this shift of minus 2, so this means it's z to the minus a, the z transform of the rest of the thing of x. So here it's going to mean 4 square z to the negative 2, and then the z transform of the rest of the thing, like without the shift. So it's n 4 to the n u of n. And then you continue from here. You see it's n times something. I mean, if you call this x of n, you have something of the form n times x of n. And this is okay now, because you know what x of z is going to look like. It's in a fairly simplified form now. And for this guy, the z transform is supposed to be negative z, the derivative of the z transform of 4 to the n u of n. So this z would take out one negative power from here. You get, okay, it was 4 square, so it's negative 16 z inverse derivative with respect to z, and then what's the z transform for this? It's going to be 1 over 1 minus 4 z inverse.
Could you scroll up just a little bit?
Yeah.
If that a to the n, u of n,
Uh-huh.
translates to c to the negative ax to c, wouldn't that be c to the negative 4 after the whole squared?
What? A to the n u of n, it translates to what? No, it doesn't translate to that. That was
That was the other one?
that was this guy.
Okay.
So this is this, and this I'm not gonna say it. It's just 1 over 1 minus a z inverse, right? So again, there won't be a formula sheet on the exam. You have to remember at least the basic ones like these. And that's what you have here for this guy. A to the n u of n. You get this. And then the ROC. So from here, like here we know the ROC is supposed to be mod z more than magnitude of 4, which is simply this. And the derivative, it has no effect on the ROC. Whatever is the ROC, that's going to stay the same. Then you have a z inverse. So this implies that z cannot be infinity. Z cannot be 0. If z is 0, this is a problem, but again the original ROC, it never included the 0, so it doesn't matter. This is the final ROC. So that's some basic z transforms, and don't expect anything more complex than this. Then this is this is on the homework, and I think we also worked this in the class. So we are given an impulse response. First, it's, let me go to a fresh page. H of n is 0.3 to the n u of n plus 4 to the n u of n. So before we do anything, which one of them is stable and which one of them is unstable?
Stable, the fourth.
Yeah, so this guy is stable, right? Is everybody clear with that? They understand why this is stable and why this is unstable? This is going to be like a decaying sequence, and this is going to be an increasing sequence. And when you take the z transforms, what are the z transforms going to look like? This would give you, again, a to the n u of n, 1 over 1 minus a z inverse z greater than a. So this would give you 1 over 1 minus 0.3 z inverse. I'm writing the ROC below it, mod z greater than 0.3, plus the z transform for this term would be 1 over 1 minus 4 z inverse mod z greater than 4. And another way to verify stability is that when you look at the ROC, does it include the unit circle? Yes, it includes